everyone, my name is Crystal Jean Pearl R. Baldado from Group 2, and I'm going to discuss about integration, standards, and interoperability. Integration challenges and general IT standards. In very broad terms, system integration is the process of connecting different subsystems into a larger system that functions as one. With regards to software solutions, system integration is typically defined as the process of linking together various IT systems, services, and/or software to enable all of them to functionally together. These include various machine systems, computer hardware, inventory, and many more. It also includes virtual components like data stored in databases, softwares, and applications. Integration of HIS. Integration refers to a moment in an interoperability timeline where different information systems are interconnected physically and logically to achieve solution delivery. The purpose of integrated HIS are systems that interconnected, providing services to clients, leading to continuous workflow and integrated information flow, and enabling healthcare decision-making. Integrated HIS is widely considered to provide higher performance in terms of quality and safety. Here are the terms in HIS integration interoperability. First is technical interoperability. This means that the ability of two or more information and communication technology applications to accept data from each other and perform a given task in an appropriate and satisfactory manner without the need for extra operator interventions. Second, syntactic interoperability is the ability of computer systems to exchange data with unambiguous shared meaning. Semantic interoperability is a requirement to enable machine computable logic, interferencing, knowledge discovery, and data federation between information systems. Structural interoperability. This provides a common agreed model of clinical or other domain concepts. This model clinically is a meaningful entity that can be shared by multiple independent information systems components. Semantic interoperability is the ability to provide meaningful exchange of information in order to the content of the message be understood by recipient, system, or process. Operational interoperability is the ability of health information systems to work together within and across organizational boundaries in order to advance the effective delivery of healthcare for individuals and communities. The last one is organization interoperability. These terms refer to the willingness and ability for organizations to exchange data. It addresses the fact that organizations can operate in different ecosystems of legislations, policies, and procedures that impact system design and use. The four different integration approaches. Message-oriented integration. This is a software or hardware infrastructure supporting sending and receiving messages between distributed systems. It relies on a set of standard messages that allow various HIS subsystems to exchange messages carrying data. Application-oriented integration. It supplies a layer of defined and centrally managed application on top of existing applications in order to support the flow and exchange of information and control logic between them by combining relevant application and processes. The main goal is to ensure all information needed in decision making is available on time and is accurate for the users of medical software application and medical tasks. Coordinated-oriented integration provides a consistent view on the information held in several separate and disparate systems, applications, and underlying services per user. These can be supplied by using an unified front-end system or by synchronizing and coordinating the various systems or application on the user workstation. Middleware-oriented integration. The software layer that lies between the operating system and application on each side of the distributed computing system in a network. This defines a set of services, interfaces, or shared methods which support the entire system. HIS integration requirements. First is flexibility. This refers to the capabilities of integration technologies towards rapid adjustments. Flexibility maintains the balance and improves productivity and efficiency of technologies. Second, real-time describes the ability of integration technologies to support transactions which require up to the second data latency. Third, reliability. Techniques and protocols practiced to ensure all transmitted data. Reliability is when you can depend and trust all transmitted data. Fourth, reusability. Use existing information system, components, or software solutions to develop new applications in a specific domain. Reusability reduces the time and cost of implementation. Reusability is efficient since it is not costly and at the same time it reduces time implementation. Fifth, performance. Refers to the performance of the system. It is how the system works or functions. Sixth, complexity. Refers to the implementation difficulty of integration technology from technical viewpoint. It is how the level of integration technology differs from technical viewpoint. 7. Maintainability refers to the ability of information system, components, and software applications to allow changes without causing any problems in other systems. Integration technologies should aim for solutions which could be easily maintained. 8. Maturity refers to the well-tested, established, and mature integration technologies. The mature technology is the better solution because the software developers, engineers, and analysts can provide successful implementation. Scalability refers to the ability of integration technologies to supply high performance to accommodate a growing feature loads and increasing demands. Heterogeneity refers to capability of interoperating of legacy new information system through the availability of proper programming language and operating system platforms. Conclusion. Information systems is the healthcare domain have been developed in different platforms, computer languages, and data structures. They are not deployed as heterogeneous and autonomous systems, and so the capability of healthcare organization is to provide quality and shared patient care delivery and improvement. This analysis attempted to clarify these issues by evaluating current solutions based on various integration requirements. The proposed evaluation had been provided a clear vision of benefits, barriers, and specifications of each integration solution for healthcare service providers, healthcare decision makers, and system integrators and providers. IT standards, imaging, and internet standards. To switch from an analog to a digital working environment, put the radiologists at the front line of producing and distributing digital images. New dedicated software products were developed such as PICS, RIS, and HIS. This also led to the development of standards for the electronic transmission of radiological images, such as the DICOM standards. In many radiology departments, teleradiology services became part of the daily workflow, mainly to solve such problems as increasing workloads, shortage in radiological capacity, demand for subspecialty advice. To summarize, the radiologist in his role as manager can make optimal use of information technology in four principal fields, namely the management of workflow, the interpretation of images, the treatment of patients, and the communication with clinicians and patients. In this data-rich environment in which the context is king, radiologists should embrace AI to simplify the process of enriching the reports with this data. Use of IT should enable radiologists to assist in selecting more personalized or less invasive treatment options for the patient. The patient should be full owner of this data and therefore should have the possibility to decide who is authorized to make use of them. A software application to make structured multimedia reports consisting of a graphic presentation of the patient. This shows interactive key images of each anatomic region. DICOM standards. DICOM, or Digital Imaging and Communications in Medicine, is the international standard to transmit, store, retrieve, print, or process and display medical imaging information. This makes medical imaging information interoperable. It is actively developed and maintained to meet the evolving technology and needs of medical imaging. It is free to download and use. For media communications, a set of media storage services to be followed by devices claiming conformance to the standards, as well as file format and medical directory structure to facilitate access to the image and related information stored in interchange media. So how does DICOM work? The two main components of DICOM are the DICOM file format and the DICOM network protocol. These two elements work together so that images are in standard and the exchange of images is also standardized. Finally, DICOM works because everybody uses it. If a device is not DICOM, no one is going to buy it in today's healthcare world. DICOM file format. All medical images are saved in DICOM format. Medical imaging equipment creates DICOM files. Doctors use DICOM viewers, which are computer software applications that can display DICOM images. To diagnose the finding in the images, DICOM files contain more than just images. Every DICOM file holds patient information such as name, ID, sex, and date of birth. Each DICOM file holds important acquisition data such as type of equipment used and what settings were on modality. So that data is all embedded inside the image. Here are the 5 main benefits of the DICOM standards. Excellence image quality. DICOM supports all 65,536 shades of gray. universally adopted medical imaging standard. All imaging devices use DICOM, making them easier to connect to the network. It has full support of numerous image acquisition parameters and different data types. It includes the patient and device information, not just the image data. It has complete encoding of medical data. DICOM devices use more than 2,000 attributes to convey precise medical data. Clarity in describing digital images devices and their functionality. Working with these devices through their DICOM interfaces is a predictable process. So here's a better representation. You have this patient in the real world. In DICOM, he is John Smith. ID number, date of birth, his weight is 75.5 kilograms. Sex, male. All information about him from the real world is translated into the data, and it becomes the patient's information object definition. Medical imaging devices create DICOM files. DICOM files contain the image data, information about the patient, and other information about the image. That's all. Thank you.